All right, so this is a review of the lower sixth Christmas exam, multiple choice questions. So we've got a graph here, some kind of current voltage graph, and it asks us what is the resistance of the electrical component when the current is I2. So we're looking at a current here of I2, and so a voltage of V2. Now, one of the common mistakes is that people think the resistance is the gradient of the graph, but it isn't in the case of IV graphs. You simply need to use the equation. R equals, let's see, V over I. So V equals IR. Always worth, if you're going in with a rearranged equation, always worth kind of checking that it rearranges to the version you know, which is, in my head, V equals IR. And so we literally plug in the values, so it's V2 over I2. And so the correct answer, and I'm just going to make my pen a little fatter, V2 over I2 will be this one right here. Question 2, which row gives the position and ideal resistance for the voltmeter? So we want to be in parallel with X, and we want an infinite resistance. We've seen this one before. Cathode ray, some number of electrons strike the screen in 40 seconds. What current is this? Well, current is defined to be the charge which flows in a certain amount of time. So the total charge that's going to flow is the number of electrons times the charge on, let's say, one electron, which is E, normally, the symbol we give to that, over some time. So plugging the numbers in here, we've got 7.5 times 10 to the 15 electrons, that's N. Charge on the electron is 1.6 times 10 to the minus 19. That's the magnitude, it's actually a minus sign with it. Divide by 40. We're not bothered about the minus sign here. Plug the numbers in, 7.5 times to 15, and divide by 40. 3 times 10 to the minus 5 amps. So our correct answer is C. Question 4. We have seen this one before, but I think we can do a better job of explaining it than we did last time. We have identical resistors. So if we consider one resistor, the resistance is R. If we consider two resistors, sort of connected in parallel like this, so imagine that one's just on its own. This is R over 2. 3 resistors, so 1, 2, 3. The total resistance is R over 3, and you can prove that to yourself using the equation for resistors in parallel. Therefore, if we plot a graph of this, of N resistors against the total resistance, then what we'll see is that it starts off at some large value, here when N is 1, and then it falls as an inverse square. So, no, sorry, not as an inverse square, just as an inverse proportionality. And so the correct answer is it decreases, but non-linearly. So it's B. Question 5, what's the current in the 2 ohm resistor? Okay, let's see, what do we know then? Well, what we're going to need to know is we're going to need to know the voltage across this 2 ohm resistor. Because then we can use I equals V over R. And if we've got the voltage across it, we can figure that out. So what is the voltage across it? Well, I think we need to find the combined resistance. So let's ask ourselves, what is R total? Well, 1 over R total is 1 over 4 plus 1 over 2 plus 1 over 1. So this is 1 over 4 plus 1 over 2 plus 1 over 1. And then 1 over all of that gives me R total. So R total is 0.57 ohms. From there, we can say, we know that the current flowing is 10 amps. So what is the voltage across these guys? So V equals IR, 10 amps across 0.57. So 10 times our answer gives me 5.71 volts. Now we can bring that back in to our equation up the top here. So the voltage is 5.71. The resistance is 2. So that's going to give me 2.86 amps, which is going to be B. Question 6. We've seen this one in a previous test, so I won't spend too long on it. Effectively, we need to find 2 points that are the same. So W and S are at like the same point in the circuit. They'll have the same potential, or U and Q. And so U and Q is the correct answer here, because W and S is not an option. Question 7. Which row shows the readings on the ammeter and voltmeter? Oh yes, we had this one before as well, didn't we? Let's see if I can get it quicker than we did last time. Okay, so these two are 20 ohms. They will have 1.5 volts across them, so we can work out the current, I equals V over R. So 1.5 over 20 is 0.075, I think, but let me just double check. Yeah, 0.075 amps. Now, through the top part of the circuit here, the current should be negligible, should be approximately 0. So we've just worked out the current in this section is 0.075. So we can see that the correct answer must be A or B. That voltmeter is going to take all of the voltage in this part. If you think about the voltmeter and this resistor as just being resistors in series, the voltmeter's got a much bigger resistance, typically something like 10 mega ohms. So it will get almost the full 1.5 volts across it, which means that B is the right answer. Question 8, resistance increases because at higher temperatures, more electrons, well, that would make the resistance go down. Becomes a superconductor. No, superconductors happen at low temperature, not at high temperature. Amplitude of vibration of lattice ions increases. That looks good. Length and cross-sectional area both increase. That's an interesting one, part D. The length getting bigger would make R go up, but the cross-sectional area getting bigger would make R go down. Don't know, how much both of them would change. That's an interesting question, but the correct answer, the more obvious answer, is going to be C here. That is what happens, especially in something like a filament lamp bulb. We saw this one in a previous test as well. So if we're calculating the resistivity, let's see, I know that R equals rho L over A, so rho equals RA over L. We know R is R, or in fact, in this question, I seem to recall R is going to be measured by V over I. A is pi d squared over 4, and L is just L. Tidy this up a little bit, we're going to get pi d squared V over 4 Li. I'm just going to check, have I got everything? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, it's counting everything to make sure I've got 6 terms. And we can see that D is in the equation twice. So the voltage is 1% uncertainty, the current is 1% uncertainty, the length is 1% uncertainty. D is 1% uncertainty, but therefore D squared is a total of 2% uncertainty. And so it's the diameter which has the biggest effect on the uncertainty. This one we did talk about in class briefly. Steel cables are typically put into a cable in order to increase the mechanical strength, make them stronger. None of the other answers are really the main purpose, and we discussed this in class a little bit. Question 11, last one here on the multiple choice. EMF, right, draw a circuit, 12 volts, heating element, so 6.5 ohms. I don't need a circuit, but it just helps me to visualize what's going on. It might help you as well. What's the energy transferred? So E equals IVT. This is power times time, where IV is power. Now, that's not really going to work out, is it? Because I've got voltage and I've got resistance. So I could say that the power is V squared over R instead. And therefore the energy, which is power times time, is going to be V squared over R times T. So this is 12 squared over 6.5 multiplied by, now it's not just 5 minutes, it's 5 times 60. 5 times 60. So 12 squared over 6.5 times 5 times 60. 6646 joules approximately, which when we round to 2 significant figures, I see, they're round. Even though we've got 1 sig fig here, or 2 sig figs here, we're still giving the answer to 3 sig figs, naughty AQA. C is going to be the correct answer. Okay, hope that was helpful, and any questions, give me a shout.